We are live with John Ball. John Ball, that I think I rescheduled you early this week. Sorry about that, John. I'm happy to talk to you today. I think I woke you up. It's like 6:45 in Australia. John's quite an interesting person. He's a cognitive scientist, an author, and an entrepreneur. His book, one of them, is the one that I have here, is called "How to Solve AI with Our Brain: The Final Frontier of Science," which is infinitely interesting. John is also CEO of Pat Inc. You can check him out at Pat.ai. And yeah, just an altogether interesting person. So, John, welcome to the podcast. Tell me a bit more about yourself and what you're up to nowadays.
Thank you, Charles. It's great to be here. It's not that early. I'm up at 5 a.m. So it's a long day and there's lots to do.
Yeah.
At the moment, uh, we've got three different startups underway. We've got the Speech Genie project, which is only just getting to the point of publicity. That's the one where we're looking at how we can train people uh, to speak a language in a nice gamified environment, basically using what our brain does to make it effective. We've got my language tools. That's the Pat angle. We recently did our book tour, and we're talking to all these universities, and people are saying we want to use it. How do we do it? And so we're just working out how to get a university license out there so people can understand the difference between meaning and knowledge, for example. And then the last one is my big killer focus in life, which is how do we make AI work the way it was intended to work? And there's been lots of discussions on the internet about, in my words, AI is not progressing. Why is that? And so that, as you can imagine, in this world where AI is just going exponential, how can you say that it's not progressing? And so I've got lots of very good scientific groundings for why we're not progressing. And yeah, it's kind of shocking when you think about it, but I think that'll make for good discussion topics.
Yeah, it's a good headline for sure. Yeah, let's double click on that one. I know that yeah, GPU architecture is somewhat limited, and the LLM model in itself is somewhat limited, and we may need the model that learns like the brain, that is one more agentic, but also I do believe the algorithm of not just scaling quantity and going more into quality, right? Why are you saying that it's not scaling?
Okay, so it's not the scalability issue. It's the fact that the original goal of AI was to emulate humans. So we need vision, we need sensors that touch, we need to move. So if you can do the original goal, so this is back in 1956, if you can do the original goals of the AI founders, you basically have robotics, which gives you driverless cars. You have speech, which gives you chatbots and a new user interface for all of our devices. And you can look at ChatGPT and you can say it's great, it's giving me results, but you can also get those same results with Wikipedia, with all sorts of online resources. It merges them together, and if it merged them together like a human would do with no errors, great. That's a great breakthrough. But once you start getting errors into your feed and you're trying to use that as some sort of knowledge, you're in serious trouble. And what we're seeing at the moment is this explosion of tools that are almost there, but you can't trust them. Companies are trying to use them and then they don't work. And so for some reason, there's two groups of people in the world at the moment. There's the people that own the tech giants, and they're very keen that everybody should be using this new tech. And you have to say, well, okay, why is that? And then they start telling you about curing cancer and giving us permanent longevity and crazy stuff like that the technology doesn't do. Um, and there's obviously a financial benefit to the tech giants. And then you go and talk to the world experts, like at the AAAI, so the American Association for the Advancement of AI, and they recently did a survey of the top experts in AI, so AI researchers, and they said, "Are we on the right path for general intelligence for this? The original goals of AI?" And 75% of them said, "No, it's not on the path." So we've got the experts saying this is no good. You've got the people running the company saying this is going to do everything, including curing cancer, maybe next year. And we've got to get over this. We've got to actually go back to the science and say, what is it that's going on?
Right. It's interesting. The original goals of AI, I mean, yeah, I'm not sure if you're talking about like Marvin Minsky, that the 80s, the 90s. Um, I'm not sure if that's also like relevant, right? Like, I think the goal of AI is just to reproduce a human brain and have us think better, faster, and just like advance progress generally. I don't think it necessarily needs to see to be super intelligent. Don't you think it doesn't need a pair of eyes? Maybe it's just like a different kind of intelligence that is somewhat alien to us that we are still yet to understand.
Yeah, I don't think so, because if you look at how brains work, we're very much multisensory. So I've got vision and hearing, and I've got the ability to move. I've got the sense of touch and taste. I've got these things, which is really what animals have. And what I do in if I'm talking about my book on the book tour, I'd show a video of a dog just chasing a ball, and the dog could turn 180 degrees around. It's sort of moving. It's on this uneven surface. There's visually very noisy backgrounds, and this dog's turning around, chasing. Its fur is flowing. It jumps up. It grabs the ball, and then it does this nice big victory lap when it brings the ball back to me because it's so proud of itself. And you think there's robots out today that are better than the old robots, but you couldn't put them on that uneven surface and throw it a ball and say go and catch. There's no capability to do that automatic stuff. You can train it to pick up something and put it down, and pick up something else and put it down, but the animal-like skills are so just exponentially better than anything that we've built yet. And so if you want to then look at what humans do, there's a great example. So I've got all the examples from the internet at the moment that are just um, crazy examples. So people say draw a map
Okay.
of Europe, right? And so you get a map, and it misspells Germany, and it misspells Berlin, and it misspells Russia, and it puts France in the wrong spot. And you think, well, that's the underlying technology of today's tech, and that's a visual type of service.
But
So if you
haven't they
have
fixed that in the latest update of ChatGPT's OpenAI DALI model?
I that's just one of the ones that's appearing. I don't know which platform that particular one comes from, but that's one of the vision generation tools,
Yeah, yeah. I
which
think they sort of fixed that, right? And the thing is like how fast that brain is evolving compared to ours. I think yeah, intelligence is about the ability to reach your goals, right? So I mean, if your goal is to chase a bull, sure. I think as humanity is just to crack very hard problem that our brains aren't able to solve. And I had various companies, the biotech companies, AI related, that went on the pod, and most agreed that we're gonna solve cancer, but probably not before 10 years. And the most optimistic one I think was like 5. And that one was a YC founder, so a bit younger, right? Like a bit more cocky. There's always
right,
some of that in
right.
the predictions. But I do think we're going to get there just because of the sheer power. And science is notoriously segregated, right? It's like silos, and people are not communicating with one another. There's a lot of inefficiency of just like us humans showing in a lab, doing shit and thinking we're productive, right? But in the end, we're just not. We're compared to an AI that can do that in silico 24/7. And I do think we're going to have major advancement. I do think these panels of AI experts are also like very much biased. And I do think that companies are at the center of it because they do have the technology and the funding to advance AI. And I think they're way more informed than professors and researchers, generally speaking. Do you agree with that thesis?
The, so there's two brain models. I want to digress once to what the brain model is before we come back to
Yeah.
that question. So what is a brain? If you ask brain experts, neuroscientists, they're going to tell you it's some sort of processing engine. It's like a computer. We
Yeah.
just don't know how it works. Now, there's another model, which is what Pattern theory is, my brain theory, which says you can't fit the computational model into what brains do. It's nothing like it. So what a brain actually is a pattern matcher where we're getting sensory information, and we work out what's going on inside that sensory information, and then we connect it to all the other things going on at the same time. And based on everything going on, we can then find, well, what did we do last time this happened? You're walking on a street, well, we keep going straight or we turn left. All of those things can be done with patterns. If you convert it into the computational model, the first problem you have is, how do you represent our conversation now? Like, you have to have, I don't know, a database that represents me and a database that represents you, and you need to pull in all of our experiences and then work out based on our experiences what we're going to do at this point. It's a horrendously complex problem as a computer, but if you take it as a sequence of patterns, well, now it's not that hard. And if you then do the contrast, well, today's AI is basically requiring us to build new data centers and get new power plants in order to feed them, in order to run the GPUs, because they're so computationally intensive, because they're statistical computing engines. If we didn't have to do it that way, well, you finish up with, like, I say it's a 12-watt brain. Lots of people on the internet say 20-watt brain. So I'll compromise. A 20-watt brain, like a light bulb, is doing all the stuff that I'm doing now, as well as all the things I'm going to be doing the rest of today. And I can do coding, and all of those things can be highly accurate. So I don't need a specialty. I can chase a ball and I can pick things up, and there's my mouse. I don't need to be programmed and trained to do it, because I just have these basic skills. And if we give the next generation of AI people these basic skills, particularly with language, we can revolutionize how things work. So in my book, just finish this point. In my book, I talk about the 5-year plan where we can take all of the world's languages, take the model that I built, convert it to meaning, and allow people from any language to talk to each other, allow us to work with our phones as devices in the same way that another person would. If we jump to, well, what's the limit of ChatGPT, for example, no matter what version it is, if I type in like Alan Turing, it usually gives me a response like, Alan Turing was a great mathematician from England. He died in 1954, whatever the details of him is. But if I said that to you, what do you think of Alan Turing? My guess is you would probably say, you mean the mathematician? And I'd say, no, my neighbor. And at that point, everything that you know about the Alan Turing statistical guy, the historical figure, it's all disrupted, because none of that matters. But in ChatGPT, if you say, what's my favorite movie? It goes, oh, you probably like The Imitation Game, and all the things relating to this guy that's got nothing to do with what I've just said.
But ChatGPT may know that my neighbor is called Alan Turing, though. That's why it's like smarter than a human in so many senses. It knows me, it remembers me. Its memory is like, how many gigabytes can we fit in that human brain? Like, I think it's like 1 terabyte, and then the rest gets deleted or replaced in some sense. Like an AI has like unlimited versions of that. So yeah, when I compare it with like a normal employee of mine, a normal assistant, a normal human, is like Charles but smarter. That's how I would describe my chat GPT nowadays, because I've prompted it well, and it also, I've used it extensively, right?
Right. So what I say to people is, if with that technology, it brings the limitations with it. So it can store everything. It's a computer system. That's what the new data centers are for, to store the different versions of the training runs that they do. But they don't learn on the fly, and we do. And brains are storing a lot more information than we have in ChatGPT today. Because, for example, I was looking for a tool to help me with Azure, so the web platform from Microsoft. I was working with another developer, and I'm asking him to enter this command. None of the commands worked for him, and so I used the AI tools. How do I set this user up so that it works? And it gives me like 5 steps, none of which I know, because I'm not an expert in the field. And then it says, do you want to go to the first step, which is really basic stuff that doesn't tell me the detail that I need. So a human being would tell me what I need to know. And ultimately, for that problem, I'm going to call Microsoft and speak to someone. But it's not just a question of more data. It's a question of the right information. And human beings sift through all of this information and give us the right answer, not just the dictionary entry or the encyclopedic knowledge.
Yeah. I think it's a prediction engine as well, and ultimately that's also one of my definition of being smart. Like very smart humans, they're good at predicting stuff. And I would even say that is intuition. How would you define intuition?
So my argument is that the prediction engine models one that requires some sort of sentience, some sort of control. A pattern matching gets rid of that. So the reason I expect the next things to happen is because I've been alive for a long time, I've been in all sorts of situations. And if you simplify my previous experiences into not the whole pattern, but a simpler pattern, when I go into a situation that has all of those patterns, the next thing to happen isn't a prediction; it's what happened last time. And so the whole model goes from taking data, processing it, coming up with an answer, to what happened last time. And that's how the energy drop takes place, because you're not doing anything to work out what's going to come next. And if you want to head towards something good, you choose the pattern that finishes with a good result, not with falling off a cliff or walking into a wall. So all of those things is just a completely different way of thinking about what's going on with the brain, and then applying it
And
to AI.
is that intuition, like not knowing how you got to that conclusion and that conclusion being good?
Intuition, I'd say it's just a pattern. We've got an outcome in one path, and we just follow that path if that's the outcome that we're looking for. There's some really fun stuff in psychology. The Kahneman book about think fast, think slow. If you want to learn what people are interested in and studying in the world, you just go on a book tour and you get all the questions from university students and professors who say, "Hey, how does this work?" And so what Kahneman says is, from a human psychology point of view, we have two modes of operating. And makes sense to me. One mode is automatic, so how we're navigating around the world. Our talk here it's all pretty much just happening. But then if you say to someone, what's 322 times 16, if you want to work that out in your head, now you've
Like 20K?
suddenly that's the slow thinking. And so a lot of the reasoning stuff that we talk about is this trying to work out what to do the first time in a novel situation. But most of the time we're on autopilot. And my example of what is it that a driverless car doesn't do today? And it's the sentience, it's the sensory
It doesn't
skill.
crash as much as a human.
Well, you've got that, but then sometimes when it crashes because it drives under a truck or it drives into an airplane because it's not trained on it, we would never do that. So it's just a different set of problems. And the question is, well, is it worth? I think the project for driverless cars is $100 billion that have been invested so far. Would you spend $100 billion on driverless cars for them to be better at lots of driving and worse at other driving? Or would you not do it and spend that money on society and other problems? That's a bit philosophical, but
No, I think it's really rational. I think humans are bad drivers and we make errors. We get tired. Robots don't. They're so much more controllable. And I think the science is it's pretty clear on that. And if we invest like more on robots driving car, we would get less casualties. We'd have more citizens alive paying taxes. So I think that would be a net win. And that one is proven, right? It's not. Yeah, I guess the question is more like, should we invest it in that or R&D to create a new model altogether? What would be like a new model altogether, not an LLM? Like, how would you restart things from scratch? Because I guess your part of your thesis is that we cannot reach AGI with the current state of LLMs and the current state of AI and how it's evolving. How
yeah,
would you
the
do that
generative AI,
differently?
as a well-known expert says, the LLMs hit a wall a couple of years ago because there's just things that they can't get past. It's the statistical model that just doesn't align with how our brain works. It can't solve robotics because in the example of chasing a ball, you can't train for chasing a ball and then chasing a brick, and then it's an exponential set of problems to solve. What we showed with human language is we can implement how language works and use it in things like conversations in chats by using the meaning of the words. And so that's in the case of generative AI, it's an exponential explosion of processing required because that's the model. In the case of the brain-like model, it's an exponential compression of the amount of information that you need to do things like language. So in 1980, MIT, a group of people at MIT and DARPA, so the heavies of the world, said we can. It's language understanding is NP hard, so it's a problem that we can't solve in real time because So as we get the information we need, it exponentially gets harder and harder, bigger and bigger, and so we can't solve it in real time. Now, you and I are disproving that thesis, because we're talking now. It's no problem. I know all the things you've been talking about, and I can think of things to say about it. So language isn't a huge problem to be solved, and yet it was sort of given up in the 80s because of that, and so statistics took over from the 90s for all of this research, and pretty much the people I talk to now aren't experienced in the linguistics part, so the science of language. And one of my friends and colleagues is Robert Van Vel, and I don't know if you can see this. That's the latest textbook
It's a
on,
Bible.
yeah, written by 20 different authors, but it explains how this language model works. And when you read it, you realize that that sequence that LLMs are trying to conquer with read everything on the internet, store everything you get on the internet into one database, and then do statistical work on it. We could cut that into a very small subset of that and do more with it.
And do you think the current LLMs won't lead to major scientific discovery?
It doesn't fit with a cognitive science model. So I'm an engineer, and if you can, I worked at IBM for 15 years fixing mainframes, and there's a lot of crazy stuff that people build into machines that work really well. Like if you got a tape drive and it's moving a tape, and vacuum tubes, there's a little sensor at the bottom that goes, oh, I've now got more pressure. It sends a signal, and that turns one of the reels, and so you've got this great automation. So in terms of the things that we can automate, whatever engineering we can come up with to do it, let's do it. In terms of let's do AI or artificial general intelligence. Well, let's look at what we know the brain does and what we see we need to do in the world. And if we don't have a solution to these problems, let's solve them. And my argument is that with pattern theory, we can solve all of these unsolved problems going back 70 years as a good starting point for the next generation. And the reason I push for the idea of language first is because it's a much easier problem to solve than robotics, where you need muscles and touch sensors and the proprioception that we've got in order to move like an animal.
Right. And your understanding of the brain, how confident are you in your pattern theory? Is that something that's solid? Is that something that is proving reproducible at the moment?
Well, the funny thing is, I've had two careers of this science stuff. So in 1983, my professor said, we're never going to be able to understand how the brain works. And for a 21-year-old, I go, I'm going to prove her wrong. And so I spent the next 20 years until 2000 just trying to prove her wrong. And that was my pattern theory stuff. I did a radio show where I was explaining how pattern matching is the solution, not processing. And then I sort of hung up the brain science stuff, and I focused on engineering. So how can I emulate this? And in the engineering phase, all of the things I was taught as a cognitive scientist, I kept coming up with, how can I solve this particular problem? Like, I can't recognize a sentence. The parts of speech is just not the right model. And then I worked out, it's because don't use parts of speech. So all the things that we're teaching the next generation, you have to be questioning, is this the right model for the next step? So how good is pattern theory? Well, it explains things like, if you have different types of brain damage, why do you have that deficit? If it was a computer and you lose, the visual part of your brain, why does it only affect vision? Because in a computer system, everything gets merged together, and one, if one answer is wrong, it just crashes the whole thing. So in terms of brain anatomy and brain damage and the different types of brain damage we get, it's very consistent with that. And then I can use engineering with the work that we did at Pat. I can use engineering to replicate language and show a tool that nobody's been able to do before, working in real time and low power.
And do you agree that, if there would be someone that would crack AGI, that would be a company like OpenAI? What about my previous statement about companies vs like typical research labs? Are companies moving like 100x faster, or is that false?
Well, when I compare the original goals of AI with what's coming out today, where and since the 1990s, we've been in a gold rush for passing benchmark tests. Uh, Most of the work that we're seeing is somebody saying, I can get 20% better in this benchmark test. Well, yeah, but can you walk across the road with your robot? No. Okay, so can you have a conversation with me? No. So all of the things that we really care about aren't being solved. There is a lot of work. And if you want to keep up with 10 companies with massive funding and thousands of people working on problems, and then look at the one or two things they do each week, you get this deluge of progress. But against the original goals, we're stuck. And so that's why it's just such a harsh comment to make, because I'd like it all to be, as exciting as it is being presented as. But when Sam Altman's saying we're solving AGI this year, he can't mean AGI the way it was originally defined, which is human level, right? Because that needs to solve robotics. It needs to
But
solve.
isn't that already done? I mean, yeah, like human level. I mean, depends on where you see intelligence. Because a kid like me, I grew up behind a screen, right? So I'm not really like that much into the physical world. And to me, ChatGPT is already way smarter than 99.9% of humans I've seen and I've talked to. So haven't we cracked something there?
Well, my example would be, give me the latest Chat GPT. I type in Alan Turing. It says Alan Turing was this guy that did that. That's not how language works. So it's got more information at its disposal than we do. It
Yeah,
doesn't
but the
understand.
Alan Turing is like super niche, right? Like I don't my metric is more every time I ask ChatGPT something, it 99 out of 100 times it'll be on point and it will excel. Rather that if I would ask a stranger or you these question, it'd probably be the other way around because I ask pretty tough questions as well. So yeah, that I feel
So
it's like
Charles,
super
that's
useful, right? And usefulness is also like some definition of intelligence, like adding value. I would add to that. Um,
okay. So
and
so
yeah,
so here's the problem. So with intelligence, if you want to use that word, I don't use intelligence because it means whatever you want it to mean. But if giving you the right answer is intelligent, then Wikipedia's got the right answers, curated by humans, and they're right. When I've used LLMs and I say, who went to the Dartmouth conference in 1956 where AI was named, you'll get an answer like Alan Turing was there. He wasn't there. So that's the hallucination problem. And
I
and
think that's
so
getting fixed though. I think it's like it's diminishing by very high rates, and us humans hallucinate a lot as well, probably more than an AI. Like I can invent stuff randomly, even when I'm sober. I may be tired. My brain might just confuse stuff. I mean, you see it all the time, right? Even if you're smart. So and that has, I think, like the stats. I'm gonna ask GPT about that, but I think initially hallucination was like 10-15%, and nowadays it's probably like less than 5%. And I think it does hallucinate when you give it way too much information, the
okay,
context window, right?
so there's a couple of problems, and the big one is the hallucination rate. I think at OpenAI is about 20%, and different systems. The measurements that I've seen coming out of the scientific papers are like up to 80% for certain types of problems. So can it be fixed? Jan LeCun, one of the um, Turing Award winners, he says it can't be fixed in principle, and there's nothing to be done about it with an LLM. You need a different technology. I can't. It's not my specialty. My specialty is in what the next generation of AI will look like. But I don't think these things are fixable because the fundamentals of how they work is just there.
I
You
think
can't change.
Jan LeCun is pretty pissed off. It's not a reference that I check nowadays. In that space is quite emotional. Um, but yet, like you can see here, for example, 3.5. That was pretty big, by the way. That's humongous, and yeah, that's dangerous also because yeah, GPT had that sycophancy problem, which is always
Yes.
agreeable. That was pretty big. I think they're currently fixing that, and see here how massive that is. They chopped it by like 3x. But what was funny is that they never really told us, like on the 3.5, that it was hallucinating so much. So I think they're making progress there, and yeah,
But Charles,
that's
this stuff's been going on for a long time. I don't know, 10 years or something. They've been building these systems, and now we're getting errors to be patched. And the original system, which did the training, was supposed to do everything. And now you put RAG and fine tuning and all sorts of tools and reinforcement learning sitting over the top to try and constrain it to better answers. And it should be possible to simply generate a system that works, not because you can tinker with this stuff forever. That was the John McCarthy model. If you give me a problem to solve, I'll write a program to solve it, and it sounds good in principle, but the number of problems that we get in the real world is infinite. So
right.
you can keep patching. Well, if I add this sentence and I get this response, then I'll do this. Yeah, okay, well, that's a patch, but now there's infinite numbers of sentences that you have to deal with. But
Yeah.
hey, I'm sort of a skeptic on the current tech. so
No,
so
but I think it's gonna be patched, right? And then, like you said, I think there's gonna be a competing model that's gonna be extremely better. And but even that system will need to be patched, right? And talking about that, do you feel that science itself needs to be patched as a discipline? Do you think that this is we're sort of reaching the top when it comes to the scientific method and how we humans think and try to make stuff predictable?
Yeah, it comes back to the scientific method and how we're practicing it. We've been practicing it in the West in recent years. So, if I should, it shouldn't be possible for me as an independent researcher to challenge the world experts, but I can because my model's completely different. They're not trained on any of the stuff that I've learned over the last 40 years now, and so it's possible to challenge it. But how it should work is to look at, well, where does entrepreneurship and innovation come from in the first place? It's not really a university thing. Like in history, the great inventions don't come from universities, and they don't come from tech giants. They don't come from let's see, when electricity was coming out, it wasn't the gas company that was driving the electricity change. It was entrepreneurs and investors
And
focused on the new stuff.
misfits.
Right. Yeah, the Apple misfits. And so in order to get to the next stage, we need to take entrepreneurship back it a little bit so that companies can get going and prove whether they are onto something better. Because at the moment, the expression is all the oxygen sucked out of the air by these tech giants and OpenAI. If you put
But Sam
$20 billion,
Altman is an entrepreneur before anything else. He's
absolutely.
not, and so was Elon, right? Like, and guess what? These guys are gonna fall also. Like, it's always an up and down cycle.
They're at the top of the field, no doubt. And Elon's got what five major companies that he's started in niches that look like they'd be really great if we could solve them. I'd love to work with his Neuralink company because I've got a brain model. He's trying to work with brains, and the current science doesn't support the approach that they're working with. So
Yeah, yeah.
there's lots of
That
things
one
we
I'll
can do.
agree with you. Like that one, I'll 100% agree with that. Neuralink, its invasive approach is not. But I mean, it's bold and they're amazing. Yeah, Neuralink is like probably one of the most inspiring companies in the world, right? But
Right,
yeah,
solving
like
paralysis.
injecting nodes in the brain, like that's pretty invasive. I'm not sure if you've seen one of the co-founder of Coinbase. They started a company, a hardware company, something you put over your head. It scans it right now, and eventually it's gonna send some kind of waves that is like less invasive. Like, are you into that nowadays as well?
I'm not into that technology. I understand the concept, so yeah, it sounds great. And I'm an engineer at heart. I always wanted to be Scotty from Star Trek, not Captain Kirk.
Yeah, these Star Trek analogies. I've checked Star Trek movies, but I think I'm trying to understand most of these. Although, yeah, I know like Grok, the AI model. I believe that was in their spaceship and all of that. But yeah, I think the world needs to become way more entrepreneurial as well. What I can see this year is that we're going to hit the agentic revolution, and I think that's going to slash a bunch of jobs. And I'm saying it because, yeah, firsthand experience. I already slashed a bunch of employees myself and replaced them with AI, and they're just performing better, oddly enough. So, do you think that the future is fully entrepreneurial? How would you paint it?
Yeah, I'd see the future where new ideas are being backed. They're also being attempted in the large corporations, because I think last time I looked, Google spent $25 billion a year on R&D, and they could do a lot of good with that sort of a budget. And there's lots of Google type companies out there. So if we can break this idea that all the good ideas are going to come out of MIT and Stanford, and then they're going to be commercialized by tech giants, then you've got a model where, I think the US almost has it with a lot of its programs, where you can get started, you can test things, and then you can bring it into industry and be successful that way. I'd
Well,
much
John,
much.
thanks for showing up today. Can you tell us a bit more, like where to find you, your book, and your company?
Sure. So the book is best found on Amazon at the moment. So, How to Solve AI with Our Brain: The Final Frontier in Science, because the final frontier in science is what our brain's doing. It's the only thing we don't have a good scientific model for, in my opinion.
Yep.
If you look at speechgenie1.com, that's the language software that we're working on at the moment. So we've got a launch coming for that as a product shortly, and that's the one where we're using how the brain works in order to teach new languages. That's probably it. Pat.ai is just sort of a placeholder at the moment. That's the big project, and we're really focused on the other two projects at the moment.
All right. So that was